Hi everyone, my name's Jonas and today I'm going to show you around Credibilityguard. This is the project that we did as part of the CRTL Hackathon on Aleph 0 and we've submitted on the Tokai platform. First of all, I'm going to just show you around the basic idea. I'm going to explain to you how it's going to work. Then we're going over to a small presentation which will show us the architecture, and then we'll look at GitHub and take a look at the code and the progress and what's been done. So what's the basic idea? Well, Credibilityguard aims to combat fake news. You know that fake news spread around very, very fast, and they appear very suddenly. And once they appear, everyone has an opinion and voices it, but nobody's really accountable for that opinion. And we dare to change that. And the idea is that we are going to enable people to upload what they think are fake news to the blockchain as a hash, and then people can go and bet on it. They can place a bet and say, well, I'm quite certain that's fake, or I'm not, but anyways, I'll have to put up some money. If I'm right, I'll have more afterwards. If I'm wrong, I'm going to lose it. This is going to give a very early idea on what's fake or not, because those people who are wrong all the time won't have any money, and those people who will be right all the time will have quite a lot of money on the platform, I think. Furthermore, people are incentivized to vote early on subjects and get higher returns if they vote early. This is going to be how it's going to look like. So we have the project overview here, which talks about how people are going to find out after the betting period what's actually true, because that's very, very difficult. We thought about asking AI about it, but there's lots of vulnerabilities with that. And what we thought is that we'd create a group of people, community, which is going to be linked very closely economically to the success of the platform, and as such, as Credibilityguard the platform, and as such, we create people who will be very motivated to find out if it was fake or not after some time. So we will issue, or we have uploaded on testnet a token contract which is stakeable, and people can go and stake their tokens, the platform tokens, which value, I guess, will be very highly correlated to whether the truth is actually uncovered on the platform and fake news are exposed or not. And those people will have to stake their tokens and will say, well, after, let's say, 60 days, I think that this was actually fake news. And if most of them agree, then those who bet right are going to be paid. If they would lie, due to game theory, they'd lose all the money. So I think they'd be very much inclined to lie. They wouldn't be very much inclined to lie. Let's look at how it's done technically, like what's the technical backbone of this project. Let me just go into presentation mode and show you that the app, the decentralized app, is made up of 4 central structs. One is the bet struct. This stores who bet on what, this is the direction, how much they paid into the pool, that's the amount paid, and how much they were promised to get if they are right, which is the amount promised. Then we just check if they've claimed the rewards in the claimed pool. Furthermore, there's the vote struct. This stores how much money the voter had staked at the moment of voting. Staking is important here because it locks the tokens to an account, and we can't have people sending around the tokens and double voting and as such attacking the platform. Furthermore, we store the cast, so what they thought is the right answer. 0 is yes, 1 is no, and 2 is uncertain, because that can happen. With fake news, there might actually be a scenario where you just don't know if it was fake or not. If most people agree that it's uncertain, all people will just get the money back they put in. Furthermore, we have this struct news. This stores the news that's potentially fake. We store the author, we store all kinds of different information about how much money was put into the pool and what was promised to those who participate. Furthermore, we also store metadata, which is the hash of whatever news content there was, plus the resources and the sources. Then we have the platform struct. This stores in mappings the structs which we have looked at before. So all the voters, all the bettors, and the news. At the very bottom, you can see that there's the CG token. This is the platform token. And we store the address of this token to check who voted, of the voters stored and staked what. This is how it's going to be. User submits a statement, which might potentially be fake news. Stage 2 is that users bet on whether they think it's actually fake or not. Stage 3 is the stakers can vote if it was fake news or not. And stage 4 is that bettors can claim their payment back, their payouts. The main functions which make this possible, obviously there's more than 20 functions, but these are the main functions, is the post function where people put up what they think is fake news, the betting, the voting, the claiming, and the pool claim. This is important because it incentivizes people to upload news because they will get a cut out of the pool which was put up on betting. And the payout is going to be substantially larger if people were very certain that something is fake or not, but the opposite turned out to be true, which incentivizes them to put up interesting news. Let's just for a minute, and then we will already done, look at GitHub for a second to look at what we've done. So in the contracts folder, we have the platform, so which is the central smart contract for the platform, but we also have the token contract, which stores staking information, and as such, we can get the stake balance off and look at this from the contract in a cross-contract call. The platform, as you can see, has the smart contract on the entire platform, and we have all these structs here, and an interesting function at the very bottom, which I have created a small Python script to try it out with and to play around with it. This is the function that calculates the premium. It does this in such a way that people are incentivized to vote on whatever people did not think is true. This is going to be important to have the possibility of current news overwhelming the majority. So thank you very much for presenting Credibilityguard, and we're already done here because unfortunately we started working on the front end, as you can see here. But we unfortunately were not able to finish. This on part is due to us not starting early enough, but there's also something else. We ran into a lot of problems with the smart contract deployment. There is this is visible if you meet the Builder General channel on Discord, where we had lots of discussions with an amazing team and a very helpful community, which did not grow tired of listening to us and sending back answers to our questions. But also we've run into some bugs which I hope are very helpful to Aleph 0 in order to increase the developer friendliness of their programming paradigms and their amazing blockchain. Thank you very much for sticking up to here and looking at our DApp. I hope that you are convinced by now that this can change fake news and combat fake news in the future and make the internet a more transparent and a more safe place. Thank you very much, and I hope to interact with you again in the future.